Hello, and thank you for watching our video on LAN switching at a high level, presented by RouteHub. This video is intended to talk about some of the LAN switching protocols and technologies, and talk about one of those technologies and a little more emphasis on one of the major dangers within LAN switching, besides span tree. So let's get started. So these are the protocols and technologies that we will be focusing on today. We'll be talking about VLANs, trunking, BTP, and spanning tree at a high level. We'll talk about some of the LAN switching hardware that can be used within a LAN campus network, and show you a couple of show commands on what some of those outputs would look like. So VLANs. So VLANs is a logical broadcast domain that can be extended across a layer 2 network. There could be a VLAN, and you can see a VLAN very similar to like maybe a subnet, that you have this very dedicated network that could be dedicated for the engineering department with their own subnet. Then you have another VLAN that's for HR, another one for finance and marketing and help desk. These different VLANs or different networks or broadcast domains. So VLANs are really two types. There's really a standard VLAN that you will configure, like we talked about, one for engineering, one for HR. But there's also a private VLAN, which is a more advanced configuration. And what a private VLAN does is that, let's say that there are two computers within a VLAN, a standard VLAN. They can communicate with each other without any issues. And most people implement things like NAC or 802.1x for making sure that they cannot communicate with each other within the same VLAN. One alternative is also using private VLANs, where you can configure different kind of communities within these VLANs, which can prevent certain hosts from communicating with other hosts within the same VLAN. The one note about VLANs is that communication or routing between other VLANs, it requires a router. So natively, they cannot communicate with each other. So if I have a VLAN for engineering, one for marketing, and they need to communicate by whatever means, it requires that there is a router in between these two VLANs in order for them to communicate with each other. So here's a diagram that reflects what VLANs would look like in a typical design. Here we have, starting out, we have two computers. We have one computer, which is 192.168.1.10, and another one on dot 11 or dot 11. And you can see that they're in the same subnet, which is 192.168.1.0. Dot 10 is the node address here. Dot 11 is the node address here. And we see that they're both plugged into VLAN number 1, which is the default VLAN on switches. We also see that there's an uplink, an interconnection link between these switches. And if we're connecting them, they can also be in VLAN 1. So you can see that in order for this host to talk to this host, that VLAN 1 needs to be extended from end to end in order for that to work. Hence, this is in VLAN 1, this port is in VLAN 1, VLAN 1, VLAN 1. So that allows communication. We also put on two other computers that has red indicated in a red connection here. And they're on the 192.168.2 network. This has a host ID of dot 11. This has dot 10. Now, as you will see that they are in VLAN 2. Now, they cannot communicate with each other because VLAN 2 is not being extended to the other switch. Only VLAN 1 is. And that introduces us to our next technology to help. How can we resolve that? And that is trunking. So trunking is a protocol that is used to carry multiple VLAN tags. When I say VLAN tags, I'm like VLAN 1 or VLAN 2. So those are like the tags across a single interface or connection. Trunking can occur in two types of main encapsulations or protocols. The most common one is 802.1q, which is recommended, and the other is ISL. 802.1q is a Cisco 802.1q, my apologies, is an industry-based trunking protocol standard. It supports more VLANs. It supports 4,096 VLANs. Then we have ISL, which is a Cisco-based trunking protocol, which supports far fewer VLANs in terms of supports up to like 1,000+ VLANs. In today's industry, with access points and voice and unified communications, 802.1q is recommended to be used in your network. And trunking, it can be used between switches with access points that we talked about, even with IP phones that could have two different VLANs, one for voice for the IP phones and one for data for like your computer. But trunking can also occur with routers, firewalls, or any other device that supports, for example, 802.1q, since that is an industry-based trunking technology. So this is the diagram that we saw with our VLAN example. That in VLAN 1, these two computers here are able to communicate with each other without any issues. However, the two hosts on VLAN 2, they cannot communicate with each other. So how do we fix that? Taking the same diagram, if we convert this link here to be a trunk link using 802.1q, I can say that VLAN 1 and VLAN 2, by doing trunking security, those tags are allowed across this interface. Doing so, now both VLANs are extended. Those tags can be extended between these switches, which can allow the hosts in VLAN 1 to communicate with each other and hosts within VLAN 2 to communicate with each other. Again, if this host wants to talk to this host, they cannot do so unless this was a layer 3 switch where those VLANs are routed. VLAN Trunk Protocol, or VTP. So this is a protocol that is used to manage and administer VLANs across a LAN switching network. And there's three main modes with VTP. There's the server mode, which is the default. There's the client mode, then there's the transparent mode. A few things about that. The server mode is the only place where we can configure and delete VLANs. Whenever we create and delete VLANs on a VTP server, those changes are propagated within the VTP domain, which can consist of very likely VTP clients, which will accept those changes. But its main distinction is that you cannot create or delete VLANs on a VTP client switch. The third is a transparent mode. And this is a device that, regardless of what is changed by the server or other VTP servers, it will not listen or take those changes that are done. So it kind of keeps its own kind of VLAN table. So that's kind of the pro side. It kind of protects with that. But there's a con, and that is if I have 100 switches and I'm adding a new VLAN, then I'm adding that VLAN on over manually in all of my switches. So the administration does go up, but it is highly recommended to be used. Now,